Hello, I'm JW. This time I have a socket to have a look at. This one here, this has been sent in by Lee. Now this is actually a brand new item. It was sold on Amazon and it's not particularly good inside, as some previous pictures which were sent in did actually show. So we're going to have a look inside this, see how well or otherwise it's manufactured. Now this is a slightly unusual device in that as well as the normal outlets and the USB jobs, this is also one of these Wi-Fi controlled things. So the switches on it are sort of momentary ones, and then presumably it switches on a relay or something inside, so they're not actually sort of just on and off switches, so it's all electronic. So anyway, let's dig in and see what we can find. So this is the socket, and say usual UK outlets there, two of these USB things which claim to be 2.1 amps, whether that's in total or each or whatever isn't clear, presumably an LED there. And then the on and off switch, which as you can see is just a sort of momentary press type of arrangement. Doesn't actually click on and off because, as I say, this is a relay controlled thing, presumably. It does have the shutters inside, so it's not terrible, but of course they are required as part of the standard, and they're just the cheap ones where if you press the thing down, of course the shutters open. And we can see there the shutters are actually opened and remained open, so that's a bit of a fail on that side. That one is kind of working correctly, but unfortunately we've just managed to jam that one shut, so definitely not the best quality. Screws are concealed, this faceplate presumably just clips on, and on the back not a lot to see there other than just the connections for the main supply, so neutral there, and we've got a couple of air terminals on each side, line in the centre, and comes in this box, sort of a papery polyester bag thing, screws to attach it, and then this is the user guide. Basically the deal is that you're supposed to install this app into your phone and then it pairs with it and does all the business and all of that. So there you have it, and in terms of any codes and whatever, well if you want to scan those, well please go ahead. Now let's just see if we can pry the front plate away from this thing. So in here is the area in question. Yeah, so it's just a plate that clips on the front, so that is just a piece of plastic, and then here's the socket thing itself. So screws would go there, and then obviously we've got the parts inside that are exposed, and then this is the one which it does work, but it's certainly on the sticky side on that one. That one is marginally better. So I think what we'll do here, we'll just shove some power onto this and see if it does actually work, and see how much power we can actually get out of the USB holes there. I mean, the actual socket part, we're not too concerned with that because of course it's just going to be the usual plug-in deal. As long as the UK plug fits in it, which it does, then not too bad there. And there's not a lot of clearance here between the actual switches and the plug, but of course there is enough. So I just connected up some wires there. The terminals are not particularly good. I mean, if you that's the line there, you could actually still touch that, so not particularly recessed. And with the wire in, the actual terminal itself does actually move, so certainly not the highest quality items. Haven't connected the earth in this case because we're not really testing the actual socket bit, it's just the USB area. Now I've got a USB thing here, and this is not powered on yet. Fits in there okay, but this one, I can't actually get it in there because it seems to be slightly misaligned, so that is a fairly poor start, given that we haven't even managed to plug anything into it yet. So yeah, the actual plate there seems to be out of alignment with the front panel, so that's definitely not good. And yes, there we go, it does go in with a bit of adjustment from the screwdriver, so that's definitely not very good. And I've actually got the thing in there, so this will just display the current, and then we've got one of these things we can just adjust the actual power from it to obviously see what sort of current we can get out of it. So the power is on, and we can see it is putting out 5 volts, so pretty much what you would expect there. And like pretty much all of these, the power is on all the time, regardless of whether the socket is actually on or not. And this is my view as a fairly large problem with these things, because having something that's literally permanently on means that its lifespan is going to be considerably shortened, as obviously if stuff's left on 24 hours a day, it isn't going to actually last long. Now the switches here, yeah, you can hear the relay clicking there, so if you press it once, there's the relay, and there's the relay on that one. So it is just a momentary switch that turns a relay on and off inside to do the 2 socket outlets. Of course, the idea is you install the app and then you can control these from your phone or whatever device you may happen to have. So in that regard, even more stuff to go wrong. And of course then it has to be powered 24 hours a day, otherwise the actual radio part in it wouldn't receive anything. So as well as wasting power, of course you've also got the issue of the electronics being powered literally permanently, and depending on how good they are, you may or may not actually get any power from it. Now let's get this in frame here. So this is basically the voltage, 5 volts or just slightly over, and then the load will be on this thing when we turn the thing on. So if we just press on the button here, now that should be actually on. Now we can just turn up the current here to see what we can get. Now this claimed 2.1 amps or 2100 milliamps there, so we should be able to go up fairly high. So voltage is sagging down a bit already, which is not particularly good, although it's still within the specifications. So we're coming up to around 1 amp there. So 1 amp and it's 4.92, which I say is not wonderful regulation, but at least it's sort of within the realms of usability. But we can continue cranking the knob. So 1.3 there. This is one of these 10-turn jobs, I think, so it takes quite a while to actually get anywhere. So 4.9 volts. Yeah, so we're getting sort of up to the 2 amp range there. Voltage dropped down to 4.89 there, 4.88, so it's definitely sagging. So just about on the 2 amps there, or about as near as we're going to get. So 4.87. Fan has come on because of the cooling there, but that's just how that thing actually works. Now, how far can we go before it actually gives up completely? Well, that's the 2.1 which it claimed, so that's a reasonable amount of power there. Yeah, we see the voltage is sagging away quite a bit now, 4.8 volts. Yeah, it's gone off completely there, so 3.8 volts there, 2.4 amps, so 2.1 seems to be its kind of limit there. Yeah, about 2.3, we're getting 4.8 volts, which is still usable, but obviously that is more than the thing claimed. So basically once you get more than about 2.3, the voltage sags away considerably. So 4.8 there. Yeah, and then it's gone sort of it goes down to about 3.8 there, 2.4 amps or so. So at that point it's going to be pretty much unusable. 3.7 volts is not going to do a great deal for anything that requires 5. So in that regard it does seem to deliver the goods in that regard. It's probably shared between the 2 outlets, these things normally are, so I'll have a look at that when we take it apart later. So let's just disconnect the power from that, and we'll remove from there. Let's just try that in the other outlet, as we might as well. So yeah, it's dropped down again to that lower current level, pretty much the same deal as we had before. So yeah, so it managed about 2.3 amps at about 4.8 volts. Anything above that voltage pretty much sags away to almost nothing. Now I can see that the USB thing is basically on permanently, a little blue indicator there, and there is actually blue showing in the socket hole as well. Not very easy it's going to be seen, so it's fairly bright in here, but there is a blue illumination coming out of it. And then we can obviously turn that off, but Yes, it does seem to actually turn on and off, but I say the electronics in this are going to be powered permanently, simply with the fact that it's one of these Wi-Fi controlled jobs, and obviously it needs power all the time to actually receive whatever it's receiving. But we can see there that the 5 volts on the USB is still there, as in 506 there. That's why we can't get in easily, even though the actual blue light is off. So the blue light is purely for the socket outlets. The USB thing, say, as with most of these, is permanently powered all the time. Turning that on so that the blue light comes on. Doesn't actually change anything. Now let's see about getting into this thing. We've seen before that the faceplate here just clips on in a fairly non-standard way. So this screwdriver slots here at the bottom. And bearing in mind that's have to be done via those, because when it's on the wall you can't go into the back to get to it. So just a decorative cover, nothing surprising there. Yeah, we can see here on this socket the actual socket is too high compared to this one, so it makes it rather difficult to get the plug in there. Sort of bend it down a bit maybe. Now on the back here we do have some screws in the middle, so let's have a go with taking those out to start with. Hopefully we don't have to remove the actual rivets or anything from that, but we'll have a go anyway. So we've got those there, and it appears that the front plate will just clip on. There's some sort of bits around the side there. Yes, that seems to be popping off quite easily. Yes, the back appears to be just one moulding, so presumably all the stuff goes in from the front, as this is not actually a brake line here, it's just part of the back moulding. So in theory then everything should be accessible from the front here. I will say that this is actually moderately warm on the back of here, presumably from the fact we were just using it on the power there. So yeah, this bit here is, it's not hot, but it's notably warm to the touch there. So let's get rid of all this business. So there's the shutters for the socket. So yeah, it's just that the usual cheapo-matic mechanism with a sort of plane or angle on the side of that, which just presses down. A little spring to return it to its original position. Same on both sides. So here's the interior of the contraption. Now this is the area where the heat was coming out of, where this transformer is located, and a few other components as well. These will be the relays here to turn the sockets on and off. A couple of switches there. And then we can see the other components are just basically shoehorned in here in any old place. So not a great deal of thought went into that. An awful lot of flapping wiring going around here as well. So definitely not of the high quality construction there. Now let's turn it the other way because that's actually upside down. So you can see these are the socket contacts here, and they're just stamped out of a single piece of metal. Not too surprising in terms of how those are constructed. Earth ones appear to be riveted through into the back. So yeah, that just comes through onto the back here. 2 rivets there onto this metal strap, and that's your 2 earth points either side, both connected together of course. You could just use one or both, fairly common arrangement. And then the 2 other terminals here, line and neutral, go through. Yes, they're just coming basically through onto this side. This is one of them here, so you can see that goes along the bottom there, and again comes up to this one, so that'll be the neutral. So it's single pole switching only. So it's just basically connecting through, and then that piece here is the neutral input on the back, so it's only switching in the line. Not that that's a major problem, because most sockets are only single pole switching anyhow. Here's the LEDs at the top, not quite sure why there's 3 of them, because they all seem to illuminate pretty much in the same area. So compared with the front plate, there's only a single hole, and then it sort of shined into the USB socket area. And then the wiring, we've got a neutral line coming off of the thing at the bottom here, which goes up somewhere there. And then we've got these red wires, which presumably is switched output. So yes, that one there goes across to the socket terminal there. And then the other one, which is this one, presumably is this bundled up wire in the middle in there. So yeah, it sort of goes round underneath that. So Yes, it does all seem to be a bit shoehorned in there. Definitely not of the decent quality. Now in the middle here we've got these two bits of metal here and here, and these are actually the contacts for the switches. You see them just in the back in here, so when you press on the switch, that's what's basically moving in the back of there, and the screws that hold the front cover in place actually come through these holes, so that will mean that the screws on the back are actually in contact with this metal here. Though they're going through the middle, it's fairly likely they're going to actually contact both of these, so in theory they may actually be having some voltage on them when the thing is in use. Now it's not generally a problem because of course the screws are on the back and they're fairly deeply recessed, and of course this would be in the wall normally, so normal operation, not generally accessible, but rather strange concept having those actually going through there as well. Now on the top here, so these are the two relays, the USB sockets we've seen. Over here looks to be the Wi-Fi receiver, just a little card there. It's actually got the sort of antenna pattern printed on the circuit board, so that's the actual receiving part, and it's got a load of vents on this side for whatever reason, and some over there as well. And in terms of what we've got here, it's going to be a fairly standard switching power supply, so this will be the transformer here at some high frequency, the usual suspect capacitors here and a couple of others on the board, what looks like a metal oxide varistor down in there. That's probably the capacitor for interference suppression, and then we've just got another few wires in here, this black one and a couple of others sort of shoved down in the bottom there, this sort of browny coloured thing which comes from over there, and presumably another capacitor in the yellow there. A couple of resistors of fairly substantial size, notably placed right next to the wiring, so if these get hot, which they almost certainly will given the size of them, could melt right through that wiring. Now the board was held in, there's a couple of screws, just one there and then one right down in there between the various components. Those don't go through to the back, but you can see there's a little pimple where the things are, so they're pretty close, but again that's on the back anyway. And as for the rest of the wiring, say it is literally just tacked in any old place. This in the middle in there, that is the line input from the terminal on the back. That is actually the terminal there, just soldered on. And then we've got this wire coming across here, just goes straight down onto the circuit board, and then the two outputs of these, one here and here. So all of the current for the two socket outlets is going via that wire there, and of course the relays and these two wires here. Now the relays are rated for, depending on what you want to read, either 16 or 10 amps at 250 volts. Obviously one for each of the outlets. I was saying before they're only a single pole switching. So anyway, let's see if we can just tease this board out of here. This really is an exercise in shoving as much as you can into the smallest space available. Definitely not a great deal of design thought was put into that. So let's have a look and see what we've got then. So this three-prong plug here, two white ones for the switch contacts there, the two on the top, and then the red is actually the common, linked across with this incredibly thin black wire to the other side of the switch. So that's pretty much what that was for. That is a removable item. The two relays there, we can just see the markings on those, NHL or somebody. So see they're running at 5 volts for the coil, and then the contacts, this one's is read 15 amps 250 volts or 10 amps 250 volts, depending on which one you care to believe. So in theory they can switch the 13 amps of a UK outlet, but whether that's actually the case or not, anyone's guess. So that's those two. Not else here, just the two USB outlets there, one of which we see is misaligned, and that's probably because this relay is pressing up against it, as these do not appear to be in line there. So in theory it could sort of squish up a little bit, but it's definitely misaligned with the casing. 3 LEDs, they're all blue and they all seem to come on at the same time, so they may have some function with the wireless app or whatever. Over this side, so there's the little transformer. Rather bizarrely, it's got two wires coming off the top here, one here, one going down to the board there, so T plus and T minus. Not entirely sure why that's been done. And then say a couple of capacitors there. This suppression capacitor across the two things there, and then we've got two of these green capacitors over here. They claim to be 105 degree rated, but so they don't appear to be any particular useful brand there. This is actually a fuse in the middle here, so at least it does have one, which I suppose is something. This rather sizable resistor. This is presumably an MOV here. Yeah, it's presumably a metal oxide resistor for some kind of surge protection. Another capacitor stuck behind, and another, possibly a resistor there on the back of that. So not a huge amount on that side. On the back of the board here, again not a huge amount here either, but we've got the various control chips for the various items there. So it's going to be one for the actual power supply, the 5 volts, and then of course there's going to be one as the controller for the actual on and off switching part. And so the actual Wi-Fi receiver appears to be on this end board here. And you notice that's a completely different style of board, so it's just a module that they've presumably bought in and then just soldered through on the main board here. So that would be the aerial thing on the top there, and just a single chip does everything. Here's a look at some of the chips there for the persons that really care. So that's an AMS 1117. It says 3.3 on, so possibly some sort of regulator there. All that's just basically a load of resistors and some capacitors. Probably a transistor or something at the top there, just for switching something, and a few more. So another one here. Okay, there's the number for that 8-pin device. Probably some microcontroller or something very similar. No doubt the one that does the control for the on and off switches and all of that bother. Over here, just bridge rectifier there with the AC in and the plus and minus on the other side. And then over here, which is presumably one for the actual USB output, bearing in mind that's the transformer there in the yellow. So there's that one. Again, a 7-pin job there. And again, just a few resistors and things on the bottom as well. Now this is the fuse on the top side of the board. I've just broken off the bottom there. It's soldered in, so any failure is not a usable, replaceable part. Just about to see there, it's a 16 amp, although it is only one of these cheapo glass jobs which tend to have a habit of exploding when faults occur. And if we just rotate around there, 250 volts, pretty much what you'd expect. So yes, it does have a fuse, although say the breaking capacity of these is generally on the low side. And bearing in mind in the UK this is going to be attached probably to a 32 amp circuit, so a fair amount of fault current is going to be available from that. Now in terms of the board, it's not particularly good. I mean, this is the line input here. This red wire just goes into the board, and then the neutral is this blue one. That goes straight to the terminal on the back, and then the neutral is actually via the copper strip here, which has the socket terminals on, as well as the terminal at the back as well. So it basically comes in here, so you've got your line in neutral here. Neutral goes through, of course, onto the bridge rectifier, and the line, of course, goes across via the fuse we had on the back, and it also goes via this resistor. So it appears that the resistor is being used as sort of a crude type of fuse for the actual power supply, and then this 16 amp job actually goes down to that K1, or that pin there, just where it says K1. And then this is what goes off to the two relays here. So the 16 amp thing is only for the socket outlets, and then the sort of 5 volt side or whatever is using this resistor as a sort of crude fuse there, or shoehorned in with the MOV and things as well. And we see that's just directly across the line there, one side to the other. Now you'll see here that there's this lump here of actual metal where the fuse has been shoved through, and it's just basically been bent over near that. So even if the fuse blew, you've got a nice conductive path there between the actual incoming line and the inputs to the relays. So certainly construction soldering on this is not in the high quality area. We have put a few slots in here for some kind of isolation there. So I'd say that's your input side of the relays, the full current going in there with a bit of extra solder on the top there to increase the current there. And so we've got a few slots here to attempt to divide those off from the rest, but certainly not the highest quality construction. And from there, say, just through the bridge rectifier here, and some goes across to the devices over that side, of course, and then the rest goes via the various capacitors and whatever over there. Now this is the output from the two relays. This is the first one, and this is the second one. So as you can see, the current will just go in here and comes out over here on this pin. They have done a bit of effort of blobbing some solder across there. But bearing in mind, theoretically you could plug a 13 amp heater in this socket. The full 13 amps is going to be going via this soldery mess and that soldery mess over there. So definitely not particularly wonderful. So a bit of a blobbing of solder there to increase the current capacity, but definitely not a very good design. Now this transformer is a bit bizarre because we can see at this end the pins go through into the circuit board as you'd expect, and so this will be the switching controller chip here, so that's all mounted down here. But then on this side there are no pins on the bottom there at all, and instead we've got these two leads coming off the top, which they go over to points on the board there and here, so one either side of the USB socket, so they're coming down over here somewhere, and they've presumably done it because they couldn't fit the pins on the board in here. Now the problem with that is that the transformer is only on one side, and we can see here it's all creaky squeaky because it's not actually fixed down at the other side. So yes, a rather bizarre design, and they haven't put any adhesive or anything else there to attempt to fix it down either. So not very good. It definitely looks like this was some kind of afterthought. They thought, oh, we'll just shove the transformer there, and oh dear, we haven't got enough space for the pin, so just put a couple of wires going over to somewhere else. So definitely somewhat suspect there. And so there's pretty much the rest of the top of there. We can see the 5 volts coming off here for the actual sockets and things. Basically it's just connected through. The middle pins are not apparently connected to anything, but then it's only for power, so of course that wouldn't actually be necessary anyway. Now just pulled a couple of the connectors off there. This is just a metal oxide varistor as expected there, so again just connected down in there. And the capacitors there, Chong brand is that, or Thong or something like that, but anyway nothing particularly spectacular there, just your usual cheapo-matic generic jobs. And there's a couple of others there which bizarrely are completely different style. Not entirely clear why they've gone for those, but nevertheless that's what we've got there. So a couple there and then the two here, and then that blue thing is just the sort of suppression capacitor, as you would expect. That damage as well. I had to ram the screwdriver in to get the screw out of that hole. It's not actually being supplied like that. So there we go. So not a great deal on there, and it's all sort of shoehorned in and shoved in with no particular care or consideration. And so all your current is going to go via these terminals here. You can see there's not a great deal of metal between those two pins. This is the relay output. This goes to the wire, goes to the socket terminal. And again, the same problem here. There's a bit more solder been bodged on there, but again, fairly mediocre. And of course, worst of all of your input current here is going via this track on the printed circuit board. And say the fuse is there, but it's a 16 amp fuse, so in theory you can get 16 plus amps going through this very thin track on the PCB here. And of course 16 amps is a rather strange value because someone plugs in, say, a couple of electric fires, that's going to be 26. And although in theory UK main socket's not actually rated to 13 amps per output, it's generally some split of one current in another and less in the other one, but nevertheless it's going to be, if that does fail, it's not a user replaceable part, and in the case of that failing, both of these will then just cease working, although the USB section of course would still continue to operate. So let's look inside a fairly poor quality USB and Wi-Fi controllable socket outlet. The Wi-Fi control only relating of course to the mains output sockets on those two relays, so it is just basically on or off. The USB part powered up all the time regardless, and that seems to be the deal with most of these. I haven't seen anything different, but the USB bit being powered up the whole time, and that really is a big problem because you're putting fairly cheap and nasty electronics in there, powering them up 24 hours a day, 365 days a year, and then expecting them to last for a certain amount of time. Now, as we all know, capacitors are fairly short-lived devices, certainly when they get hot, and this thing was getting fairly warm even with the short time we loaded it up there. So life expectancy of these is going to be pretty poor, and I've actually got another one here which has failed, which another person sent in. We'll look at a later date. That failed after only a couple of years in use. So whereas in the past your normal socket outlets, say just with the thing there, install one of them, it's probably going to last for decades. But if you're going to start putting in these USB things, they're probably going to fail after only a few years, or maybe even less. So it seems kind of wasteful there. And of course the other problem is that these USB outlets in themselves can become obsolete, because say these ones just provide a certain amount of power, but 2.1 amps at 5 volts. Although a few years ago that was pretty much the latest and greatest. Of course these days with USB 3 or the USB-C type connectors and all that business, then a lot of these now provide far more power than that, as they have negotiable voltages and all kinds of other stuff in there. So even if you fitted these, they're already becoming obsolete. So even if they don't fail, replacement is going to be fairly likely, because of course new devices use far more power and expect to have better facilities available from the chargers. So anyway, that's it for this time, and if you want to send stuff in yourself, then please do so. You can find details on the link in the description to this video, and until next time, thanks for watching.